Everybody, chapter 3 is a really long chapter. I think it's the second longest in the book, but that's no big deal because I think it's pretty clear also. It just covers a lot of ground. There are some places where it gets into experiments, and that's okay. You know, some of these experiments are dated, some recent, but some dated. And occasionally you'll find a few that have a lot of conditions, but I think Galati does a good job of explaining things, and sometimes they're really, really self-explanatory, like the section on face perception. So I really enjoy this idea of perception. I enjoy optical illusions. Optical illusions can explain so much of our experience. We bring experience to bear when we're perceiving things. So if you'll just indulge a definition or two. If we've taken sensory input and interpreted it, that's perception. You've received a pattern, objects, people, and possibly events in your world. You might not consider it an achievement, but we do it every day. And sometimes we have to fill in the blanks. Some computer scientists try to create artificially intelligent systems that have discovered just how complicated perception is. And neuroscientists have estimated that areas of our brain responsible for visual processing occupy up to half the total cortex. And if you remember from the previous chapter, that was the occipital lobe. The question for a cognitive psychologist, and strictly speaking, that's what I am. A multi-millionaire cognitive psychologist. I'm kidding. But the question for a cognitive psychologist is how we manage to accomplish these feats so rapidly and usually without error, but occasionally with error. So for now, we'll adopt what might be called the classic approach to perception, defining it. And figure 3.1 illustrates this. And we'll get to that here. Here's figure 3.1. Out in the real world are objects, events, things that we perceive. And each of those objects is a distal stimulus. For a living organism to process information about these stimuli, it must first receive the information through one of the senses. And it's easiest to talk about vision. The reception of that information and its registration by a sensing organ make up the proximal stimulus. In our early example, light waves reflect from a tree or a car to your eyes, and in particular to a surface at the back of each eye known as the retina. And we don't get into vision very finely, thank goodness. But it's understood that we're alluding to that. So the meaningful interpretation of a proximal stimulus is that percept, your interpretation that the stimuli are trees, cars, people, and so forth. And from the upside down, backward two-dimensional image, you basically see something. In other words, I had to repackage the whole thing. You also recognize that, say, the giant oak tree is closer to you than are the shrubs, etc. So here it is. I've got a distal stimulus, a book, let's say. It's that proximal stimulus, the retinal image of the book, which is upside down, backwards, incomplete maybe. And from there I have the percept. I recognize a book based on my life experience. Now sometimes that life experience, as we'll see, can induce errors. And on the other hand, sometimes the life experience can fill in blanks that are kind of hard. For example, let me fast forward just a little bit, if you'll indulge me. This is one of my favorite things to talk about. This is an example. I should have had this ready, pardon me. I'm going to owe you one. I'm about to show you an example of top-down processing. You may have seen this bottom paragraph, and it reads as follows. According to research at Cambridge University, it doesn't matter in what order the letters in a word are. The only important thing is that the first and last letter be in the right place. The rest could be a total mess, and you can still read it without a problem. This is because the human mind does not read every letter by itself, but the word as a whole. That's my percept of those words. My proximal stimulus is still messy, but I'm able to reconcile it to some degree based on the context. For instance, when I see what is clearly Cambridge and there's a capital U after, well, heck, that's got to be university, especially if it ends in a Y and the rest falls over like dominoes. So that's an idea of our perception. Now that was badly degraded, but nonetheless, I could still glean meaning from it. So that's one of the miracles of our perception. However, that because we know what was intended, sometimes you can fail to catch typos. I went and visited my dissertation in Tuscaloosa back in 2012, and this was just a few years after I had defended. I think I defended in 05. I did defend in 05. And I pulled it off the shelf in the library, and I was absolutely appalled that there was a rather horrible typo in the dissertation. Now, how could that happen after me literally reading it a few hundred times? Well, I knew what it was supposed to say, and that's the way it met my brain and became a proximal stimulus or a percept as I was reading it, because I knew what it was supposed to say. So over there, I have a roughly 20-year-old dissertation that is got a rather awful typo in it, and I accept responsibility, but I understand how it happened. I don't think I was sloppy or sloppier than most. It just one of the ways in which we are fooled sometimes by intent. So researchers studying perception disagree about much. They agree that percepts are not the same things as proximal stimuli. Consider an example from size constancy. So if I extend my hand as far away from myself as I can, and I'm looking at my fingers now that are probably, 40 inches away from me, maybe just 36, but basically I'm making an adjustment. I know that my fingers are longer than an inch taller, so although that's the impression that's left on my retina. So that's the idea of size constancy. Related to perception is a process called pattern recognition, and we'll speak of that with some dots later. This is the recognition of an object, event, or so on as belonging to a class of objects. So your recognition of the object you're holding, that you're looking at as belonging to a class of things called, say, shrubs, is an instance of a pattern recognition. A giraffe is a pattern. You've got the four legs plus the extended neck, etc. Because the formation of most percepts involves some classification and recognition, most of, if not all, instances of perception involve some kind of pattern. So I'm not just seeing the components of the giraffe, I'm formulating it together. We'll return to this and get to some Gestalt approaches to perception. But one of the things I hope you'll believe about this chapter, as long as it is that it is appeals to reason. I think that's a good way of saying it. We'll have so many examples that I think you'll be convinced that they're reasonable. And I think Gestalt, or I should say Gestalt, is one of those.